In our lesson today, we will cover one more factoring method, which is the difference of two squares. You learned it last year, but we haven't reviewed it yet this year. It's my favorite because I think it's absolutely the easiest factoring method that there is. And then we also will talk about the rhombus, which is a special parallelogram. So everything we learned the other day about parallelograms is still true, and there are a few extra properties for these very special parallelograms. First, difference of two squares means we are factoring something that has a minus sign in it. And it means the two things before and after the minus sign are each a perfect square. We can take the square roots of them. So we have a perfect square minus a perfect square. So if we want to factor that, we take the square root of the first one, and we write down two parentheses that both start with x. And we think what is the square root of the second one, and both parentheses end with that square root. And then we put a plus sign in the middle of one parentheses and a minus in the middle of the other one. So if we have x squared minus 100, we can take the square root of the x squared and have x and say both parentheses start with that. And everybody gets square root of 100. So both parentheses end with a 10. One of them has a plus and the other has a minus. And it does not matter which one you write first. So let's look at a couple of examples there. X squared minus 25. Everybody shout out nice and loud. What do both parentheses need to start with? What do they both end with? And in the middle, one has a plus and one has a minus. However, what about x squared plus 25? Is that a difference of two perfect squares? There's not a minus sign in there. This can't be factored. It works only when there's a minus sign in the middle. This one, we don't know what it equals. It just says factor. So that means leave it as parentheses times parentheses. And we're finished. Although, as we saw the other day, if we know what it equals, we can make sure we get everything on one side so that it equals 0, and then we can solve it by factoring, which means we get x equals. On the top one, example 1, if you then set x equals plus and minus 5, that is wrong, because you have no idea if x squared minus 25 equals 0 or something else. You can't go farther on the first one. The second one we can. I'd like to do this second one two different ways. Do we have a minus sign? Can we take the square root of 144 and of s squared? What is the square root of 144, everybody? So we can write two parentheses that both start with 12s. If it equals 0, can we take the square root of 36? Everybody, what is it? So end with a 6, one of them with a plus, one of them with a minus. That means 12s could be 6, so s could be a half. 12s could be minus 6, so s could be minus a half. We found what the variables equal. We factored it, so we wrote the parentheses times parentheses equals 0. We solved, we got numbers for the variable. Another way I could solve this one, does it have a GCF? What do you think the GCF is, Mateo? Okay, you can take 36 out. Other classes have said 2. Oh, no, it's 4. No, it's 12. It's actually 36. I'm not sure this way is any easier because it's a little hard for me figuring out 36 is the biggest factor on this one. And then a little bit hard, 36 times what is 144? I think it's 4. S squared, does that look right to you guys? And then minus 1 still equals 0. So then I have 36 times 2s plus 1, 2s minus 1 equals 0. 36 equals 0 is nonsense. 2s plus 1 equals 0 means 2s is negative 1, so s is negative half. 2s minus 1 equals 0 means 2s is plus 1, divide by 2's, and s is a half, and I got the same answers that way. Questions from anybody on those two problems? Okay, we'll do one more just to get one that could be messier. So we want to solve this. Is it already equal 0? Yes. How many terms do we have? We just have two things. We have a minus sign between them. So we're wondering if it's difference of squares. Can we take square root of 121? Can we take square root of n squared? What is the square root of 121? So both parentheses can start with 11m. Can we take square root of 64? Shout out, what is it? So plus 8 and minus 8 equals 0. That means 11m can be minus 8. So m can be minus 8 over 11. Not a very nice answer, but that's okay. 11m can be 8. So m can be either positive or negative 8 over 11. Yes, ma'am. After you've shown the work with factors, yes. Any other questions? Then let's move on to our other topic for today. Well, we'll review all the factoring methods first. So far what we've learned about factoring. Always look for a GCF first. Usually if there is one, it makes it easier. Although again, that 36 and 144, I'm not sure. Then look at how many terms there are. If you have two terms, the only thing we know right now besides GCF is difference of squares. We'll learn another one later if we have a cube plus a cube or a cube minus a cube. But right now we can only do square minus square. If it's three terms, and if it starts with 1x squared, we'll factor it with two parentheses that start with 1x. If it starts with something else, 3x squared, 2x squared, 12x squared, at least one of those parentheses has to start with something besides 1x. And we have to use the AC method. If they start out with four terms, see if you can do a GCF at the first two, a GCF at the last two, and get matching parentheses. Because there are a few problems where they don't start with the AC method, but they start you off with four things. And you just see if you can factor by grouping. So any questions on that review? That's what's in your toolbox right now for factoring problems. Don't see any hands up, so now let's go on and get ready to talk about a rhombus. A rhombus is going to be a special parallelogram. So let's see if, without looking, we can remember the 5 things about a parallelogram that we wrote down the other day. So a parallelogram is a shape that looks kind of like that, where the left and the right are parallel, the top and the bottom are parallel. And that was our definition, that opposite sides are parallel. Okay, there was something else about opposite sides. Does anybody remember what's also true about the opposite sides? Hear it? So opposite sides are also congruent. Please notice as I'm writing these down, this is about the shortest way that I want you to abbreviate these. I don't want everybody just making up their own things like OSC or OCS or COS. They'll all be making it up a different way. So write out just enough. That's not that much writing. It's not going to hurt you. We're shortening the words. We're using symbols when we have a symbol. Okay, so opposite sides are parallel, opposite sides are congruent. There were also some things we learned about the angles. in these figures. Nicole, do you remember one thing about angles? Opposite angles are congruent. If you look across, you've got two acute angles. Those have the same acute measure. The obtuse angles have the same obtuse measure. So opposite angles are also congruent. And again, that's not bad. We've got standard abbreviations, standard symbols for angles and for congruent. And we can shorten opposite. Just a few letters there. There was another thing, another way we could look at angles in a parallelogram and come up with something. Rick? So the adjacent angles add to 180, which means they're supplementary. So we're going to abbreviate that. Adjacent, ADJ, the angle symbol, and that they are supplementary. The last thing that we learned about parallelograms was something about the two diagonals. Amelia? A little bit louder. And what do they bisect? You're on the right track. You've only had one thing. They bisect each other. So the diagonal between the obtuse angles is shorter than the diagonal between the acute angles, but from the middle to one acute angle is just as long as from the middle to the other acute angle. From the middle to one obtuse angle is just as long as the middle to the other obtuse angle. And we abbreviate that with diagonals bisect each other. And we're going to see in a moment why we can't just say diagonals bisect, because there's two different ways they bisect things in a rhombus, not in any old parallelogram, but in a rhombus. So I have to write out a little bit more. There is no symbol for bisect. So everybody good with those 5 things, a definition, and 4 other things reviewing? Okay, now we're going to talk about a rhombus, and you don't really need to write this next part down. It'll be on the formula list for the next page. A rhombus is a quadrilateral with 2 pairs of parallel sides. Oh, that's just the definition of parallelogram. So a rhombus is a parallelogram where all 4 sides are congruent. And that's what we're going to put in our formula list. A parallelogram, and all 4 sides are congruent. We can either say the measures are equal, or we can say the sides are congruent. If I put a bar over it, it means the actual line segment for the side. If I don't, it means how many inches long it is, or centimeters, or whatever my units are. So we can say the numbers for the measures are equal, or the shapes are congruent. 2 more properties, and they both have to do with the diagonals in the rhombus. So if I draw the diagonals now, because it's a parallelogram, from D to the middle is just as long as the middle to B, and from A to the middle is just as long as from C to the middle. Those diagonals still bisect each other when we talk about the line segments. But if it is a rhombus, see what I've marked in red. The diagonal from D to B cuts both of those big original angles in half. 2 equal halves on either side of it. Same thing from A to C. That diagonal cuts the big angle A in half and the big angle C in half. And the opposite angles are still congruent, which is why both sides are green or both sides are red, but the opposite angles are still congruent. For that one, we are going to need to abbreviate it as diagonals bisect, not each other this time, but the angles, and we can use the angle symbol for that. This one, if we're using it, we could basically say definition of a rhombus. our final property about the diagonals, they do still bisect each other, but they bisect in a special way. They not only cut each other in half, but they cross at 90 degrees. Now it's important that we keep our vocabulary and our symbols straight. Perpendicular, the symbol is the upside down T that looks like it makes a 90-degree angle. And perpendicular means they cross at 90 degrees. Bisect means they cut each other in half. In this case, they cut each other in half. Being an angle bisector means they cut the angle in half. There is no symbol for bisect. Do not use the upside down T for bisect, because upside down T means 90 degrees. So if we are using this last property to say that we have a 90-degree angle, we would say diagonals are perpendicular, if that's the part that we were needing. Emma? So what? If we are doing a perpendicular slope, not just any old slope. So it still is at the upside down T. In that case, it's still saying 90 degrees. That's the only thing that can make. Any other questions? Then we have one example where we use these properties and we write down our abbreviated reasons on it. So here is our problem, and this picture is a little bit distorted by the projector today, but it's a rhombus because the words say so, and because all four sides have one tick mark on it. It never matters what it looks like, it matters what we are given. If it looks congruent, but we don't have congruent marks or words that tell us that, then it's not congruent. We can't use that. We can't use it looks that way. In this case, it doesn't look like the sides are all congruent. Doesn't matter. They are because the problem says so. So if this is a rhombus, and we need to find all four of those things, I think Z is the easiest. Who can tell me how big angle Z right here needs to be? From the properties that we just wrote down a little while ago. Right? That has to be 90 degrees. It already has a degree symbol on it, so we'll just write 90. And our reason, diagonals are perpendicular. Who can tell me now something about X and B down here in this bottom left corner? Is there something we now know about X and B from the things that we just wrote down? Evelyn? Not just X and B adding up to that. We'll get to that in a minute. I wanted to start with just X and B first, but hold that thought for a minute. Haley? X and B are equal to each other because the diagonals bisect the angles. Now, Evelyn, what were you saying adds up to 360? Perfect. That's the next thing that we want to say. If I take X and I take B, and M goes all the way around there, if I take all three of those, I get 360 degrees. And that was circle sum. We know M is 306. And if B and X are equal to each other, I can substitute and make that either 2B plus 306 or 2X plus 306. Subtract 306 from both sides and we have 54. So how big does X have to be? 2X is 54. Elias, how big would X be if 2X is 54? What do you guys think? 27 sound good to you? Does to me. So that means x is 27 and b is 27. That just leaves a. And a is this angle over here. And there are at least a couple of ways we could get a. So I am open to suggestions. How can we get a? There's more than one way, so I need to see some hands going up. Brad, give me one approach. With which triangle? Okay, with Z, and so Z, so going from the middle to P to O. Okay, so we could do triangle sum with this, but I don't have that one up there, do I? You're right, we can get there. And that will be one of the ways we do in a moment. Does anybody see another approach that we might want to use on that? Jack, what are you thinking? Equals how much? And a plus 54? 2a, okay. So we could say this is also a because diagonals bisect the angles. So then that means this whole big angle of the original P would be 2a. So 2a plus, and we know this is 2x or 2b, and we know 2x is 54. So we know everything at that original angle M is 54, and that has to be 180. And our reason for that would be adjacent angles are supplementary. So then we could subtract the 54 and get, I think 126 is 2a, so everybody, how much is a? 63. If we did this with triangle sum, we would have to say that angle NOP is also 54 because opposite angles are congruent. And then we could say angle MOP is 27 because diagonals bisect the angles. And then we'd have a 27 in there. Then we could do the triangle sum, that 90 plus 27 plus a is 180. And we'd solve that, and we would also get that a is 63. Questions from anybody on that? And you'll often find now there's more than one way you could look at a problem to get there. So sometimes go with the first idea you get, sometimes that should work, anything else that might be shorter or easier, and then pick whichever one you like best.